Okay, hello everybody. I'm Francois Chabot again. I will explain you a bit today what Rotoblast is, what Rotoblast can offer, but I will mostly focus on the recent update from the company, what has been just coming out, or the new knowledge that we've gained over the recent years, and some case studies and research updates. So we can see mass timber evolve very quickly. Every year there's new studies, for us, new connectors coming out. So we have to keep up with this and try to optimize our design and our building. Just before I start a bit, I want to briefly recap the product range, let's say, from Rotoblast, what we offer. Most of you probably know us for the screws and the connectors that we offer for the mass timber building that you can see here. But we also offer other products that are completing the building envelopes and better buildings. So we have also a range of tapes, membranes, special product for airtightness of the building. So we want to, yes, be sustainable, but sustainable not only with wood, but also with the airtightness of the building, the energy consumption. We have a range of acoustic solution to improve the people that are living in those wood buildings. Acoustic is a big part of mass timber. It needs to be quite related, so we have a big range of products for that. We, of course, have some tools to go for the installer of the mass building, some special tools, so some generic one that can help facilitate and install the project. And we have also a line of safety equipment, lifeline, rail guard, everything that you need for your project. So basically, we are a multidisciplinary manufacturer. We try to optimize the building and to look at all the aspects of it. So the fire resistance, the acoustics, the high performance, the disassembly of the building also, which is more and more talk of the hour. Disassembly, you will see it with some of our connectors that we are proposing, and we're looking at also for a longer term building life cycle, let's say, and then moisture and everything. So we'll start a bit with maybe the screws. I won't talk too much about this different screws that we have, because we have plenty, but I'll talk about a bit something different. We just launched a timber screw smart book that we call. If anyone wants to have some copies, it's available back there. It's pretty interesting. We put into this all our knowledge that we gained in the past years with all the university that we're working on with. And it's a good resume of everything about corrosion, shrinking and swillage with wood and screws, fire resistance, and all the installation method that is also a big topic for those big buildings. So one of the first things as a designer that you kind of need to know to choose the right screw, I would say. This is one of the basic. You have to know what's the service classes that you are building in. This is the European service classes, but in Canada we have about the same, just a little bit less categories, let's say, but we can easily get into one of those categories. You have to know what is the atmospheric place that you are. If the screws will be exposed to a corrosive environment, I'm saying the screws or all the connectors or anything mostly. So you have to choose where you're standing. Is it like a regular houses that you're building, or something's close to the sea where you need a more resistance coating? And some things that we found a bit lately also is that the pH of the wood itself, of the species that you're using, can play a big role into the choice that you need to make with the screws. There's few categories here depending on the pH and the water quantity on your inside your wood. So what you should consider to choose the screws, basically, you need to choose the material that you want to use, steel or stainless mainly, that's what existing at the moment. You have to choose what type of coating you're needing. There's plenty of coating that existing, and I'll show you a few of them. You have to choose the right coating appropriate to what we just saw before. The moisture into the wood, moisture content, atmospheric, and the timber acidity are all part of it. And basically, we made some sort of kind of chart. You probably can see it there, but anyways, just to help people to choose the right coating with all the range that we are offering, depending on those points. And often that's what we see in building. People just mention they want the screws, but there's not much detail on all the rest that has a big impact. Just to point it out, on all our data sheet, you can find the resistance of the screws. So in this case, it will be a special coating over the screws to resist more corrosion resistance. Some things that we also found is the tannin in the wood itself. A lot of people used to think that more the tannin you add in your wood, the more you would have a corrosion on your screws, which is not exactly the case. We found out that it's more the pH that dictate this. And basically what we found is that even when you have high tannins in some wood, the tannins kind of gather around the screws and make a protective coating by itself. So you can see a bit here, you would have some rust on the top because it gets in this case it's exposed to water. So the water wash out the tannins, so there is no protection around the screws. And when you go down inside the wood, the tannin protect the screws, so there's no more rust out of it. This is a little, well, not a little, quite a big study that we did for that. So you can see after 1 month we have different coating. Basically, our regular screws is that you can find is the zinc coated screws. Then you have organic coating. We have a C4 Evo that we're calling it's a steel screws with a special coating on top. And you have the stainless steels version. And even in stainless steels, you have plenty of different category there. So you have to choose the right stainless steel that you need. What we see from the bottom here is after 10 months, the regular screws, the most common one, the zinc coated, has some sign of rust, and it also bring all the tannins from the wood close to the screws. It kind of attract them, let's say. We found that the organic coating was one of the most resistant with the tannin here, and also the Evo coating, and of course stainless then resist much of it. Another big part of the design, let's say, is the wood or the swelling of the wood during construction. You can quickly imagine also if you insert screws, especially with the steel plate and timber connection, if you have a thin plate and the wood try to swell due to high moisture content during the site installation, the thin plate will deform and everything should be fine. But if you have a very thick metal plate, the screws, not the screws, but the metal cannot deform with the wood, so the metal will stay completely straight, and it will bring very high stress into the connectors. So you can see just here, just by having a 6% different humidity in your wood, so going from a 10% to a 16, which is pretty much common on glulam get out of the factory at 10, 12, then you easily can go to a 16% on site if you have exposed to weather for a long time. We found out that you can have almost double the stress value in the screws in traction. with thick metal plate again. And yeah, just this not look very good, but we've seen that a few times in the past and in some buildings, so that's some things to really consider. And the question that we are facing now is how to calculate in the engineering phase and to account for this type of thing that's gonna happen. And we're still researching onto this topic. Installation also is a big study topics that we did and we're still looking into. We have to, depending on the species, the density, you will have some torque limits into the screws you're gonna face. The bigger problem that we have here is that the torque is different within every species, but even in different section of a wood, because you will hit some nuts, you will hit some more dense section. So one screw can go easily in, and the other one will have a huge torque that is getting into the screws. This make a nice little picture, especially the red one that you can see. This is for the pre-drilling. We often say, or people looking for screws that don't require pre-drilling, but actually there's quite a good benefit to have some pre-drill. Basically, you can diminish your distance between each screw, and the reason is pretty much here. On the left side, you can see screw inserted with no pre-drilling, so you can see a bit the damage in the fiber. We just put some dye into the hole after, so it gives you an idea of what the damage the screws doing to the wood fiber compared to on the right, yeah, a screw that has been inserted with a pre-drill holes in it. So that explains also why you can reduce the spacing when you have some pre-drilling. So yes, our screws goes into the timber with no pre-drilling, but there's good advantage of still doing a pre-drill. Impact driver and non-impact driver. This has been a talk for a long time. Some says yes, some says no. We made also a big study very recently all about that, and what we found in the end is that impact driving during the installation has not really any impact if you are doing a wood-to-wood or a wood-to-wood connection. But if you're doing a metal-to-wood connection, that's where you have a very high impact. And this, from our side, we say it's prohibited basically to use impact on metal plates. Just showing a bit some report. We did some very big screws, 516 inches screws, testing on that for the impact driver to see if we see any difference. This also show a bit another good view of what's happened. On your left, you have these screws that's going in on a thick plate of metals with a regular screwdriver. And on the right, you have the same, but with a thick metal plate, but with an impact driver. And what happened is often, especially these days, we have very high voltage impact driver. So you keep getting in, and then the screw basically starts ripping some fiber. And then the question comes, and this is still maybe on studies, is what's the impact on the calculation or on the resistance. So we have some, based on those topics of studies and what we're keep looking into, we have some optimized design of screw that are coming out, some new coatings to face the corrosion that will probably come out, some specific Canadian market screws that will be launched in the near future. And then it goes to this question. If anyone thought there was already too much choice, be prepared, there's going to be just more. It's not, it's just the beginning. Now we can look a bit at the new connectors that we launched for the mass timber, basically. This is a connector that can withstand very high loads, and it comes in many different sizes or different application option, let's say. The main point of this is you have some place in the connectors so you can accommodate some little angle during installation. That's the main thing. When you come with a very huge beam on site with a crane, there's no tolerance. You're looking at a lot of problems. So those little play will help for the installation, and also we look with this connectors for having something that can be disassembled in the future. So that goes back to the previous thing. We're looking for sustainable buildings. If we want to take this building out in 100 years, technically we could. This connector also allows some rotation and some little rotation at the end of the connection, which make it a kind of a pin connection, and it helps on the design with the engineering. Some image here that you can see. We have an example out there. We have an ETA on these connectors and ICC coming out soon, and we're still doing some testing also. This is also a connector that we launched, I would say maybe 2 years ago, something like this, for high-rise building. This is what we call the pillar. It's made to pass the load vertically from the column to the column and not passing by the slab, which make the design to reduce the column size. So it's also making the building more cost-effective, more sustainable. Yes, we wanted to have it in wood, but having too much wood for nothing doesn't bring up anything better. And I have my colleague Hannes here who is coming down because I'm about to get into a project that we did in the States with this connectors. He was more involved into this, so I think he knows a bit better than me. Let's speak about the projects coming in.
Yeah. Thanks, Francois. I'm Hannes. I'm a CEO of Rotoblast USA, and I've been intimately involved with this project here, the Webster project. So this was the first Type 41A prescriptive building in the United States. So in the US, the 2021 building code introduced new building types that allow you to build buildings up to 18 stories in wood as per code. And this has been the first example of this. The building topped out a few weeks ago in Oakland in the Bay Area in California. And in this project, we were looking at close to 1,500 pillar connectors. And it was in many ways special because it was since the Brock Common buildings, the Brock Common building in Vancouver, BC, which was also an 18-story building, also post and plate connection. So post and plate means, as you see, there's no supporting beams with the system. You have the column, and then the load is transferred through that pillar connector onto the lower column. And there's no supporting beams for the panels. So the panels are they're point supported on those columns. In this project, with the point supported system, they moved really quick. They built 2 floors per week. Each floor was a little under 10,000 square feet. And they pull it off in time, so on schedule. For us, it was 85 tons of steel. So with our logistics, we specialize both on rush shipments, small shipments, but also big truck-sized deliveries. You see some pictures of the connector in action. So it's been pre-assembled on the yard. An interesting fact was that, so it's a 17-story wood building on a 3-story podium in concrete. To build one concrete floor, they had 15 trucks of material delivery, and for one wood floor, they had only 2.5 trucks of fiber delivery. So that was a great example of how efficient also in logistics, downtown, high density areas, how to leverage the advantages of timber there. As you see, this product right here is a LVL based product for the columns and the plates. And the project was also a great example of how to leverage, or that it was a great example that showed that we're still not there. Timber, there's a lot of friction in the delivery process, in the design process, in the permitting process, and there's still a learning curve that everyone's going through, the industry as a whole, and also the design community. There's a lot of redundancy still and a lot of inefficiencies in the design. In this project, for example, they started out with a 7-inch panel, and then through testing, because that's what the software told them, that's what the formulas, the existing models told them, they had to have a 7-inch panel. But then through testing, they were able to push it down to a 5-inch panel, which was a huge cost saving. And there's, I think the numbers are probably not in yet, but they had a lot of savings in the concrete work in the foundation. Some of the savings are specific to the market, like it's a high seismic area, so the building is much lighter. So they had the foundation of this building cost them only half what a comparable concrete building would have cost them. Then they delivered the project, or they're on track to deliver it in an 18-month timeline instead of a 24-month timeline. And they claim, so they're saying there's savings of 15 to 30% compared to a comparable concrete building that they incurred with this. It's also a unique project because the designer, it's done by a developer, but they're a developer, owner, and also architect. So it's kind of a unique setup that they had there. So this is the construction process. It takes them 1 day to set the columns for the entire floor, and then another day to fly the panels. And today they're delivering, they build 2 floors a week, and on their upcoming project they want to push that to 3 floors a week. And this has been the crew's first building. The parties for Webcore. It's a concrete builder, concrete contractor out of California, and engineer was DCI on this one. And so we got involved with the design and customization of the pillar connector here. The spider connector is the bigger brother of the pillar connector. With this you can push the spans to 23 by 23 feet, while with the pillar connector you're limited to 10 by 15 feet, 10 by 20 feet. Okay, I'll hand over back to Francois. Thank you.
All right, so yes, the spider, just to continue, same things. The goal is to have columns and columns and no under beam under the slab, so you get a clean visual. You can pass your duct, your pipe, whatsoever all you want, so you give a bit of flexibility there. That's the point of this connectors. This is a project that was done in Europe. Yeah, I'm not too much aware of the project, but yeah, basically you can see that there's no underbeam. It's the only column in the CLT slab. Then it brings the fact, if you use the spider and you want to have a wider grid, let's say, you will need to have some rigid connection into between each panel, like the center panel here. At first, we started with a glue. We have a special glue called the Z-Box, made for steel to wood, basically. We wanted to have this connection with a steel plate, but this involves a lot of works on site. It's working pretty good, but it's just that it's a lot of work on site. They need to insert the steel plates and glue it there. So we came up with another idea or another connections that we have now and that we launched that we call this TC Fusion. So basically, it allows to have a gap between the two panels, which in the other case, that was mainly the problem is that you need to align your holes on both of your panels pretty tight, and it didn't allow any movement on site, which this connector does, because you have a gap basically in between two panels, and you pour some concrete with some screws and some bars into it, and then you can just have a plank underneath to hide the concrete for not seeing it. This can all be done also in a prefab shop. It doesn't need to be done on site, so the only thing on site would be the pouring of the concrete, basically. This is different option to hide the joint behind. You can have a visual wood plate. You could cut the CLT and then keep some portion out of it. Yeah. This is all about the testings, because we just had the ETA on to these connectors, which is based on calculation. So we went into a wide range of testings for that to support all the design methods. Which brings us to another category of building now. We'll go out a bit of connectors, but it's all the building envelope, the air tightness. For having a very good sustainable building, you also need to look into your envelope of the building. That's why we have a wide range of different type of membranes. This is just a house down in BC. In BC, they are pretty advanced into the codes for having more air tightness things, so they use a lot of different membranes and tape that people have regularly on the market. It brings just to, this is not an innovation, but I wanted to brief you a bit. Basically, now in these days, there exist two types of membrane that you can find. Either you have some microporous membrane, which are the most common that you can find on the market. Microporous, it's cross fiber if you look at the microscope, and the humidity will pass through those little holes. And another kind of type of membrane, less known, I would say, that need to be pushed a bit more, is the monolithic membrane. It's made by a film instead of being some cross fiber. And the advantage are quite high compared to the microporous in terms of durability, UV resistance, stretchiness or tension, and permeability also. And just I bring just quickly. I just want to show you basically the two things. That this is a microporous membrane with different product that it takes. Basically, if you do like this, you will still have all the wrinkle into it. It doesn't go back to its place. And if you try to break it, it's not very long that you can tear it out apart. So basically, those type of membrane with UV and long terms, they start performing as they were supposed to at the beginning. And they have a shorter life compared to microporous membrane, which you can fold and they kind of take their shape back, and you can also stretch them very, very well, and they go back to their position. So those type of membrane will last very longer as compared to the other one. This is some testings that we did in Canada on those membranes to pass the local codes, self-adhesive membrane that we have on the right. Yeah, actually we passed a test that goes for high-rise building and windows when they shoot water on top of it. And then it brings us to also another type of membranes that we call smart vapor control. This is our climate control range. We have a few there. This is also a bit different, and people are not used to it in the market. Basically, those membranes, they act as a vapor barrier. It goes inside as a vapor barrier when it needs to, and when the humidity get too high, it kind of open itself and let a bit some permeability. So it allows your wall to dry over time if you have some water over in your wall, and it will also act kind of as a barrier from the humidity inside of your building, not to go out. This is really important. We saw cellulose in the presentation before. This is the type of membrane that are really important for this. Just some picture of some passive house type that we did in Quebec, actually. And also it brings to a other type of new products that we are having. It's everything that is concerning fires. Fires is a big topic in mass timber. So we made some research and launched a few products that have some fires resistance for the building envelope. So we now have quite a good range of fire solution. We just did a real testing out in the States actually for adding protection with the CLT fires to the National Fire Protection Association. Wanted to see if with the CLT wall they needed to add other protection for the outside membranes. Actually, we tested with our Traspir Evo, which is the monolithic version, some of our tapes, and then silicone. And it was found out that the CLT itself can withstand the fire, so you don't need to have a fire resistance envelope after that. This goes back a bit with the screws at first, but also it's touching fire, so that's why I put it here. It's also important to choose your connectors based on your fire resistance you're looking at, because the steels will kind of conduct the heat, and it can, as you see from the picture here, it can kind of burn a bit the wood more. So it also has a big importance on the design. So you can see going from the left to the right, first you see like a bolt, which is a big diameter things compared to a screws, which has a smaller diameters. What is the difference? And then you can see on the left, going to the right, if you have a screws that is flush on the top of the wood, one it's a bit countersunk, and then you go deeper and you can see the difference of the fire that will have the effect on your surface on your wood. So the choice of connectors can also have a big impact. Soundproofing to have better buildings to live on. We just also launched a manual with a lot of design testings for acoustic in mass timbers. This is some tests and interaction that we did basically. And we are at the moment doing some testing in the States for having more North American type of floor assembly, let's say, with some values here. Yep. So fires also a big part of this. And this is also a new membrane that we got for the acoustics performance. It can act as airtight and then waterproof, and it goes under the slab with the building. We also working, as I said, on tools or installation to help a bit. This is a new tool that we launched for lifting panels, basically. But we keep looking into the installation, which is a big part of all the connectors that we have. So this brings to the end of the presentation, basically, and how can Rotoblast help you? We have a wide range of different products. We can touch most of the topics. So basically, we're here to help make your buildings come to life and be more sustainable and better. Thank you.
So, questions for Francois?
If you have a question anywhere, we are down there. My team will be happy to go deeper on some products, anything.
Well, thank you, Francois, for the amazing presentation. I thought it would be pertinent to come back to a point that came up in Ryan's presentation and ask how many of your products have environmental product data available?
For the membrane, you mean most?
Yeah, for like you mentioned, it's not common for like membranes, tapes, a lot of these other products to have environmental product data available. So, is any of that available with Rothablast?
Yes, it's all available on our website. We have I don't know, something like 15 different type of membranes that have this CPD that we call. But yeah, this is a intern research project that we launched 2 years ago, something like this. And the goal is to have all our products fulfill this, but it takes a bit of time to get there. But yeah, we start with the membranes, and we already have a good chunk of choice there with this.
All right, wonderful. Thank you.
Yep.
Thank you, Francois, for the presentation. My question is about the moment-resistant connection in the slabs that you need when you have longer spans.
Yep.
You use concrete, epoxy. Is the fire performance of these connections equivalent to the CLT slabs? Do we need additional measurements to protect them?
Yeah, the one with the Xepox. Yeah, you need to, depending on, you will need to hide it in some wood to protect it from the fire, depending on the fire resistance that you need. And with the one with the concrete, the connection, yeah, we did some fire testing into this to see the result. We have a full study that we can share out of this. Thank you.